In Section 2b, we're going to focus on factorization. By the end of this lesson, you should be able to factor algebraic expression using 3 different procedures. Our first technique is called factoring out common factors. The second technique I'm going to go over is the difference of 2 square factorization, and finally, perfect square factorization. So in our first example here, our instructions are to fully factorize. So let's look at this 3x squared plus 5x. Notice that the x is in common in both terms. So if I divide out that x in both terms, that leaves me with a 3x plus 5 inside the parentheses. So looking at problem B, I notice I have a 4x in common in both terms, but also have that negative sign at the very beginning. If you have a negative here at the beginning, you want to factor it out. So I'm going to make my common factor for a negative 4x. So if I take a negative 4x divided by negative 4x, that leaves me with 1. If I take 8x squared and divide it by negative 4x, that leaves me with a negative 2x. So that is my factoring out common factor answer. In part C, this time I have a binomial that is my common factor. X minus 2 is in my first term and my second term. So we'll take out an x minus 2 as our GCF this time. And when I divide this first term by x minus 2, it leaves me with a 4. And when I divide the second term by x minus 2, it leaves me with the 3. So I have x minus 2 times 7. Now we don't like to write the number after a binomial. It's traditional to always write the number first. So I would rewrite this as 7 times x minus 2. For our example D, we're going to work this a lot like our last example. Again, we have x plus 3 and x plus 3 in common in both terms. So that's going to be my common factor this time. So I'm going to look at my first term, which is x times x plus 3. And when I divide that by my GCF of x plus 3, what that's going to leave me with is simply x. In my second term, when I take that term divided by x plus 3, I'm left with x minus 4. Combining our like terms in our second parentheses, I end up with 2x minus 4. Now you should see this anytime you have a GCF. Notice that I have a 2 in common in both of those terms in the second parentheses. That means you are not fully factorized this problem yet. So you now need to factor out that GCF. So I'm going to take the 2 out, and it leaves me with x minus 2, which again, I'm going to write my number first. So I'm going to have 2 times x plus 3 times x minus 2. And that is a fully factorized answer. Example E is a little bit more challenging because at first glance it's hard to see what our common factor is. But I notice I got a 4 plus an x and a negative x minus 4. And those are very, very similar to each other. So I'm going to just rewrite this slightly different. I'm going to change my 4 plus x to x plus 4. And then now I'm going to factor out that negative 1. If I take a negative 1 and divide negative x by negative 1, I get x. And divide negative 4 by negative 1, I get positive 4. And now it's easy to see that x plus 4 is my common factor that I will be factoring out of each of these terms. So let's do that. We got x plus 4. When I divide this first term by x plus 4, it leaves me with an x. When I divide the second term by x plus 4, it leaves me with a 1. And that is my completely factorized answer for part E. Now let's look at our next method. Our next method, we're going to use a rule that we learned in our last section, that a plus b times a minus b is equal to a squared minus b squared. But we're going to go the other direction, and we're going to look at the factorization of 2 squares. So if you're given a perfect square minus a perfect square, you need to know that factors to a plus b times a minus b. So in this example, our directions are to fully factorize each problem. We have x squared minus 4 squared, and we know those are perfect squares because the square root of x squared is x and square root of 4 is 2. So I can rewrite this as x squared minus 2 squared. and it follows our factorization of two squares. So my answer would be x minus 2 times x plus 2. For example B, we have an x squared minus 81. First thing I need to recognize is I have a difference of squares. I have x squared minus 9 squared. So I'm going to factorize this as x plus 9 times x minus 9. So notice it doesn't matter if I write the positive term first or the negative term first. Let's try a little bit harder one. Now we have 4x squared minus 9y squared. But this is still the difference of squares because 4x squared is the same as 2x, quantity squared, and 9y squared is the same as 3y, quantity squared. So my first term is 2x plus my second term, which is 3y, and my first term minus my second term. And you have completely factored this problem. In part D, let's get just a slightly more challenging. We have 36a squared b squared minus 16. Again, I notice I have perfect squares because 36a squared b squared is the same as 6ab quantity squared. And I can rewrite 16 as 4 squared. So I have a square minus a square. So using our rule above, this should be 6ab minus 4 times 6ab plus 4. But again, remember, if you ever see a common GCF in any terms, you are not done. You must factor out those GCFs in order to fully factorize this problem. So in this first parentheses, I need to take a 2 out. That leaves me with a 3ab minus 2. But I also need to take another 2 out of the second parentheses. And that leaves me with 3ab plus 2. Putting our numbers in front and multiplying them together, I get 4 times 3ab minus 2 times 3ab plus 2. Now the method I just did here, it's often easy to forget to factor out your GCF. So I want to show you another way to work out the same problem, and that is to factor out your GCF first. So first thing I notice is that a 4 is in common in 36 and 16. So let's take the 4 out first. And that leaves me with 9a squared b squared minus 4. Then looking at the parentheses section, I notice I still have the difference of squares. So I can rewrite what's in parentheses as 3ab quantity squared minus 2 squared. And I can use my difference of squares factorization method above and rewrite that as 3ab minus 2 times 3ab plus 2. And of course the constant 4 is still out in the front. Now either one of these methods gives you the correct answer, but it has been in my experience as a teacher that it is much easier that in this first method here that you'll forget to take out that second 2. So I highly suggest that you use the second method. It is just much simpler and you're less likely to make mistakes as you're working through this problem. The last factorization method we're going to look at is perfect square factorization. And this one you just need to be able to recognize the pattern. Notice my first term and my last term are perfect squares. And so if I have an a squared plus a 2 times an ab plus b squared, it will factor to a plus b quantity squared. And if I have a negative 2b, that term will factor to a minus b quantity squared. So let's try a few of these. Our direction is going to be the same as what they've been for all of these. We're going to be fully factorized. Okay, let's look at A. We have x squared plus 10x plus 25. So the first thing that screams out to me is I have an x squared and a 25. X squared is a perfect square. Square root of x squared is x. And 25 is a perfect square root because the square root of 25 is 5. So I might have a perfect square factorization. I just need to check and see if 2 times the square root of the first term times the square root of the second term gives me my middle term. Let's try that out and see. So If I take an x, I know that's a perfect square. I can rewrite that as x squared. And then I need to check and see if 2 times the square root of my first term, so the square root of x squared is x, times the square root of 25, which is 5, plus my last term, the square root of the last term squared. So let's see, that's x squared, that checks out. 2 times 5 times x is 10x, positive, and then 5 squared is 25. So this does follow the pattern. So my answer would simply be my first term, square root, plus my second term, square root, quantity squared. So I get x plus 5 quantity squared as my fully factorized answer. All right, let's try example B. Again, I want to check and see if I follow the pattern. Now the first thing that screams out at me is I have x squared, which is a perfect square, and 49, which is a perfect square. So I have a possibility of having a perfect square factorization. And again, just need to make sure the middle term fits. So let's try and see. I think this is going to be x minus, since I have a middle term that's negative, I'm going to think this should be x minus 7 quantity squared, if this is a perfect factorization. So to figure out if it is a perfect factorization, let's check and see if the pattern holds. So according to this, I have x squared minus 2 times the square root of the first term times the square root of the second term plus the second term squared. And if that gives me back my original equation, then yes, this is how you would factor it. So let's see, I get x squared, negative 2 times 4 times x is negative 14x, plus 49, and that is my original problem. So my factorization is correct. It should be x minus 7 quantity squared. Again, we have a perfect square on both ends. So I can rewrite, I think the square root of 4x squared is 2x. I have a minus sign, so I should have minus, and the square root of 1 is 1. So let's check and see if the pattern does hold. So my pattern should be this first term squared, so that should be 2x quantity squared, minus 2 times the first term, which is 2x, times my last term, which is 1, plus my last term squared, so that should be 1 squared. Let's see if it gives us back our original problem. So that's 4x squared minus 4x plus 1, and that is the original problem. So this does follow the perfect square factorization process. At first glance, D looks a little challenging because 2x squared and 8 are not perfect squares. But then I notice, wait, I have a GCF. So let's factor out the 2, which is in common in all terms. Now, with my new polynomial inside the parentheses, I do have a perfect square factorization because x squared and 4 are perfect squares. And I just need to check and see if it does follow the pattern for the middle term. So let's try it. I think this should be 2 times the square root of x, which is x. I have a positive term, so I should have plus, and the square root of 4 is 2. Quantity squared. Now let's check and see if the pattern holds for my terms. So I take that first x and I square it, so that gives me x squared, plus 2 times my first term, times my last term, plus my last term squared, which should be 4. So we get 2 times x squared plus 4x plus 4, and distributing out the 2 gives us 2x squared plus 8x plus 8, which is our original problem. So I know that my factorization does check out, and this is an example of perfect square factorization. In example E, I also have a GCF of 2 that's in common. Remember, if I have a negative here in front, we must take that negative out when we take out our GCF. So I'm going to factor out a negative 2x from all 3 terms. In the first term, that should leave me with an x squared. In my second term, that should leave me with a negative 14x. In my last term, if I divide a negative 98x by a negative 2x, that gives us a positive 49. And then what screams at me is I have an x squared, which is a perfect square, and I have a 49, which is a perfect square. And I just need to check and see if the middle term follows a pattern of negative 2 times a times b. So I think this should factor out as a negative 2x times the square root of x squared, which is x, minus the square root of 49, which is 7, quantity squared. But let's check it and make sure that I'm correct. So we start by taking the first term and square it, so that gives us x squared, minus 2 times our first term times our last term, plus our last term squared. So again, a negative 2x times x squared minus 14x plus 49. And notice that's the same as this factorization up here. So this one does check out. I don't have to distribute the negative 2x if I don't want to.